Hello and welcome back to our Python course. And today we have a short session about tuples and handling errors. These are two things that did not really fit very well into the rest of this course, but they are very important. You should know how to do them, and so we have a special session for them. So the one thing is tuples. This is a very easy concept to understand. A tuple or tuple, I'm not exactly sure how to pronounce this thing correctly, is a data structure that is just like a list, but you cannot modify it after you have declared it and after you have given it values. So it is an immutable list, means it cannot be changed. A tuple is different from a list in the syntactically when you look at a code. So here we have a piece of code, and you see my list is 10, 20, 30, and my tuple is 10, 20, 30 with round brackets instead of square brackets. That's the only difference. And with the round brackets, Python knows that we want to declare a tuple. And so this is all there is, and it works otherwise exactly as a list. Here I have a student info, which is like could be a list. Now it's a tuple, it has different types. Then I can print a list, I can print my tuple, I can print the student info. So let's just do that. And you can see here at the bottom what this looks like. So here's my list, here's my tuple, and here is another tuple that I'm printing out. So why would we do this? Why would anyone create a tuple instead of a list? There is no compelling reason to use tuples instead of lists. If you find it easier, you can always use lists. But you need to know tuples at least passively. When you read code, you need to understand what's happening when you see a tuple, right? You just read it as a list, despite the fact that it has round brackets. But the thing is that sometimes programmers use it. It's considered good style when you know that the values won't change, when these are constant values. So let's say you have, like we did in the previous session, we made maps with GPS coordinates of the battles of Alexander the Great, let's say. And if you have something like this, the battles of Alexander the Great, then you don't want these GPS coordinates to ever change. He's not going, back in time to change where his battles happened. So these values are always remaining the same. And by using a tuple in this way instead of a list, you signal to the reader of your code that this is not changing. This is a constant. GPS coordinates for Paris are a constant. They are not going to change. So I can use a tuple. You might also use that to protect your data. So let's say you are responsible for handling passport data, personal information of people in some kind of administration system. Let's say you are the programmer of a system that manages personal data for your company, right? Human resources. And there you have all this personal information of people. And you want to prevent your program from accidentally, due to some programming error, deleting this information or changing it. And so by making the information a tuple instead of a list, you're signaling to the reader of your program. And you're also protecting yourself, because actually the program cannot change these values, that these values are immutable and they're supposed to stay as they are. So that's all there is to it. And I personally, I've very rarely used tuples. In most of your homegrown programs now in the humanities, there is not much for which you would use an immutable structure other than using a list, right? There's no benefit to that. Okay, and you can, see this here if you want. Here we have a list and we change an item, right? We have an original list, 10, 20, 30. We print it, then we change the last item to 99 and we print it again. And you see here that the list has changed. That's a list. So a list is mutable. And now I try to do the same with a tuple. So I have my tuple, I print it, and now I try to change it. This is commented out because it will cause an error. Let's activate it, and now we do it. And now I get an error here. The thing explodes because tuple object does not support item assignment, right? I cannot do that. I cannot accidentally change it or even intentionally. It's just impossible to change it. Okay, so the next thing we want to talk about is error handling. Until now, we pretended that errors don't happen in programs while they run, but this is not the case, right? Errors happen all the time. The user can enter something wrong. We did have a few conditions where errors could appear as a result of the user interaction. So for example, we had enter two numbers and then I will add them, right? You remember at the very beginning of the course with the input. And there you use input. And because input always gives you a string, if you want to add the numbers, you have to typecast them. And the typecast can go wrong if the user actually enters something that's not a number. If the user says hello, then the input will accept this because it's a string, it doesn't care. But then when you typecast it, your typecast will explode, right? Instead of being able to typecast hello into a number. And this is something you don't want to happen. You don't want your program to stop working and produce error messages just because the user has entered something that you should not have. This is where good error handling is important. So as long as you are the programmer and you are your only user, which is what you are doing now during this course, it does not really matter, because if your program has an error and explodes on you, then you just go and you fix it. It's okay, you read the error message, you know what to do, you fix it. But when you have a user, you give this program to, let's say, your grandmother because it stores recipes for her cookbook or something, and then she enters a quantity, accidentally in the wrong unit, and then suddenly this program doesn't work and it crashes, then this is not what you want, right? And you will freak out your grandmother. And you want to make your program look reliable. The program should reply, it should say something. If the user enters hello instead of a number, the program should not just stop. It should say, I expected you to enter a number here. Please enter a number. Don't enter hello, right? You should not do this, Dave. So you expect your program to give back a message that is understandable. And so this is what we are doing here, handling errors gracefully with try and accept. Try and accept is the construct you use for that. So let's see, here we have a problem with this code. We have number 1 is 10, number 2 is 0, and then we have the result number 1 divided by number 2. And obviously this is not going to work because this is mathematically impossible. It's forbidden, right? You cannot divide by 0. Here we have a division by 0, and so we are not allowed to do that. Now, again, this is not good, because if this was a calculator, the user is entering numbers and dividing them, and now accidentally he enters 0. Perhaps he didn't even want. He wanted to say 10, but the 1 key on the keyboard was a little stuck. He entered 0, and now suddenly the program doesn't work anymore. It's collapsed, it's crashed, and nothing works. This is not what you want as an experience, right? So we want to catch this error without causing this problem. And this is where we can use try and accept. Try and accept is a block construct, like all these other blocks we know. In Python, we had blocks for if and else, and we have blocks for loops, for and while, and we have the with block when we open files. So this block structure is very common, right? And this is another one of those, try and accept. Try, afterwards you have the colon, which initiates this block, and then you have a block of code that might cause an error. So this means try the following code, but it might not work. But if it doesn't work, wait, tell me, don't stop the program. And then we have the accept block, and this accept is run only if an error occurred in the try block. So that's how you do this. And so let's see it in action. Here we have an actual example. Number 1 is 10, number 2 is 0. Try, attempting to divide. Then we have the risky operation. And if it works, we say the result is result. And then we are finished. The accept is like an else, in the way that if the try succeeds, the accept is never executed. So we continue after that. But if the result here causes an error, an exception, then it will stop executing the try block and jump into the accept. Print something was wrong, you cannot divide by 0. And then again, print the program continues on. This will happen in both cases. So let's try it now. And you see, I had it at 0, so something went wrong. You can't divide by 0. While if I put something sensible in here, let's say 5, the result is 2, and the program continues on. So that's the idea. And now there are a few refinements of those, a few things you can do to make it more interesting or to handle the error more gracefully. You can, for example, distinguish between different errors. And all the errors that Python can throw at you, actually this is the technical term, errors are thrown by your program and they are caught by your exception routine here. And all the errors that Python can throw at you have names, and you can find out these names. You can ask the program to print the name, and then you can catch the error with this name specifically. This allows you to give different messages because, let's say, again, you have a calculator and the user can either, divide by 0 because the second number is 0, or he can say the second number is hello, and then you have an error in typecasting it rather than dividing by 0. So it would be useful to know which error the user caused, not just to say error, but to say you should enter a number if you said hello, or you should not enter 0 if you divided by 0. So then you want to distinguish between the errors, and this is what you can do here. So again, try and put your age int of age input. So here we have the typecast. Next year you will be age plus 1. And if the typecast failed, you're going to get a value error. And then you say this is not a valid age. Please enter a number. So we can try this. Please enter your age, 45. Next year you will be 46. Please enter your age. Hello, this is not a valid age. Please enter a number. Okay? And so we can catch specific errors. So other errors will not be caught by this. Only value errors will be caught now. And I can combine multiple of these except blocks if I want to catch multiple errors. So here enter the first number, enter the second number is the example I just mentioned. We go and convert them into floats, then we divide them, and then we print the result. And this can go wrong in different ways. I can either, have a typecast error because the value is wrong, then I get a value error, or I can have a 0 division error if I divide by 0. And I can have multiple except blocks, so this is my try block, and then I have an except for the value error, a different except for the 0 division error. And in this way, I can distinguish the two. Okay, I don't think we need to execute this, we just saw it, right? And the last, most complicated example we will talk about, I can try something, and then I can have a value error, a division error, and an else error, right? So the except without a particular error is executed always if the others are not. So it's like an else. And then I can also pass it this exception as e thing here after the except. And this will take the exception and call it e, and e is a textual representation of what went wrong. So this e contains actually a printable text that I can print out and that informs the user of the error, right? So this is a rudimentary way of doing this. So now if I execute this, enter a number and I say 0, then it says I can divide by 0. Let me delete this one moment, or let me just, I will not delete it, I will just comment it out. Then you can see what happens if I say 0 without actually having an exception for it. Then it says an unexpected error occurred, division by 0. And this division by 0, this text comes from here, it comes from this e, because this is what this exception object, is. Its textual representation is the string division by 0 that I can print to my user. So which one is the right way of doing things? Of course, if you are alone, if you are the sole, programmer and the sole user of this, then you don't need any of that. You just let it crash and read the error message, which is essentially what you would get here. This is part of what you see as a default anyway. If you have an actual user, the best thing, the ideal, would be to catch a different error for every possible error condition and to print clearly in the language of the user also, right? For example, if it's Chinese, in Chinese, right? French, whatever language your user uses, to print a very clear message, what he did wrong and what he has to do to rectify it. But perhaps you don't always want to do this, or perhaps you don't even know what mistakes your user will make. Perhaps you are not thinking that anybody might enter hello into a calculator. And then you wouldn't think of that. And so it's a good idea to always also have this except exception as E at the end, so that you're able to catch an error and to print a message that makes some sense, even if you did not anticipate this error. And now when you have let's say again, a Chinese user who does not speak English, then it's a kind of a problem. Will you actually usefully use this exception as E? Because if this prints in English and the user doesn't speak English, that's useless. So perhaps then it would be better to just use an except without the E, just use a generic except colon, right? Which just brings you down there into this block. And then you print a generic message in Chinese. Something unexpected happened. Please call this number for help. So then you would at least give your user, you wouldn't give him a precise message what's wrong, but perhaps they don't even need the precise message if it's English and they don't speak English. So then perhaps it's better to give them something that they do speak, a Chinese message, even if this Chinese message is less precise, right? So this is a thing you have to weigh as the programmer. What kind of message would be most helpful to your user? This is a very useful thing now, the try except block, for all sorts of things. You can use it also for files. You remember we opened files, we read files, and there's always a possibility of giving the wrong file name. Then you get an error, could not find the file, could not open the file. There you can use the file not found error. Or you can even use it with import statements. You can say, and I mentioned this when we had Folium, right? You can say import Folium and in the try block, and then you have an except block, pip install Folium, import Folium. So if Folium is already installed, the import will succeed and you don't install it again and you continue. If Folium is not installed, then it will be installed at this point, and then again it will succeed and you can continue. So this is great because it avoids installing something like Folium multiple times, which at least costs some of your processing time to always go through installing the Folium. I don't know how much it actually installs if it's already there. Does it really install a second copy or not? I'm not sure how Google has optimized this. But anyway, you can improve the situation by putting the whole thing into a try except block so that the install happens only if the import fails. And there are two more. Did I just say this was all? It's not all. There's else and finally. You also have a generic else. What should happen if no exception happened is the else. So this runs if we were successful only. So it's the opposite of the except. Try, except, else. If there was no exception, then this runs. And finally, always runs at the very end. Thank you for using the program. You can dispute how useful these things are. I mean, the finally also runs if you just continue and fall out of the block. There's probably rarely the case where you want to have the finally run only in conjunction with the exception. Okay, so that's that. We are finished. That was all about error handling, and in the beginning also tuples. Try to remember these things for future programs. You will meet both of them in future programs also in this course. And I will see you again in the next session. Thank you and goodbye.